Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Norauni binti Rosmi. My metric number is 198502. The topic that I will present is the superconvergence of discontinuous Galerkin finite element methods for linear neutral delay differential equation. Next is introduction. Firstly, the continuous Galerkin finite element methods has been introduced by Xiong and showing the superconvergence for delay differential equation with several terms. Then, Delay and Zichang has extended the idea of Xiong by approaching for discontinuous Galerkin methods for delay differential equation by finding the L infinity error and the nonlinear stability. Then the other researcher has extended the idea of Xiong for their research. Basically, this study is an extension for Qin and Xiong. This is to determine the superconvergence of discontinuous Galerkin finite element methods for linear delay differential equation for neutral types. Our target is to propose the superconvergence of discontinuous Galerkin finite element methods in the linear delay differential equations of neutral types. Next, we will continue with the research question, which is, does superconvergence occur in the discontinuous Galerkin finite element methods for linear neutral delay differential equation? Next is the objective. They have two objectives in this paper. Firstly is to show the discontinuous Galerkin finite element method is superconvergence for linear delay differential equations for neutral types. The second one is to investigate the superconvergence of discontinuous Galerkin finite element methods for linear neutral delay differential equation. Next is the scope of research, where we need to take the considerations of the superconvergence of the discontinuous Galerkin finite element methods for linear delay differential equations of neutral types. Okay, we will continue with the methodology. They have three methods that has been proposed in this paper, which is firstly discontinuous Galerkin scheme for neutral delay differential equation. The second one is the linear stability for the discontinuous Galerkin method. The third one is the element orthogonal analytical method. Okay, I will explain the first method, which is discontinuous Galerkin scheme for neutral delay differential equation. Okay, basically, equation 1 is the neutral delay differential equation with delay tau greater than 0. And then equation 1 will become a linear ordinary delay equation, ordinary different equation system with delay when tau is greater than 0. So, when tau is greater than 0, equation 2 will be obtained. And then, we will solve the delay system, which is equation 1, by the discontinuous Galerkin methods and divide the interval with the uniform mesh, which is equation 3. And then we will define m degree discontinuous finite element space that has been shown as equation 4, where we can see that Pm1n denoted that the set of all polynomials of degree is less than m on the In, and then we can find the right limits of discontinuous function v at the boundary points Tn. We also can find the left limits of the discontinuous function v at the boundary point Tn. And lastly, we can also define the mesh point that has been obtained from the equation v. Then, the m degree discontinuous Galerkin methods for equation 1 also can be defined as equation 5. And also, the discontinuous Galerkin method can be interpreted as a time-stepping scheme, where if u is given on the times interval yin, 1 is lesser than n and lesser than capital N, the m degree discontinuous Galerkin solution will satisfy the equation 6. Where v is an element of Pm and 1n. Okay, next is the second method in this paper that has been proposed in this paper, which is linear stability for the discontinuous Galerkin method. As can be defined, as stability results for the discontinuous method can be applied to the linear case where FTU equals to lambda u, and by taking V equals to UH in the discrete weak formulation equation 7, and we will obtain equation 8, where equation 8 is equivalent to the equation 9. And then after summing over all elements and we will obtain equation 10. Consequently, u power of 2 h tm over 2 minus with u power of 2 0 over 2 is less than lambda interval omega u power of 2 h dt, which gives the stability results, which is provided that lambda is lesser than 0. Next is the third method that has been proposed in this paper, which is the element orthogonal analytical method. We will continue with the Legendre polynomial equation that has been stated as the equation 11, and then we will integrate the polynomial in and generate another family of the polynomial, which is the great equation 12, and we will have the following quasi-orthogonal property in equation 13. And then for all the p plus 1 order Lobato points, and equation 14 will be introduced. The exact solution u will be assumed to be sufficiently smooth on the each element Jn. The function u bar prime s into the following Legendre series, which is equation 15 with equation 16. Both sides we will integrate, and we will obtain equation 17. By using the integration by part, we will find equation 18. And lastly is the expected result, where they have two expected results in this paper. Firstly is the superconvergence of discontinuous Galerkin finite element methods for delayed neutral differential equation is expected to be solved by the proposed approach. The proposed method expected to be reliable to solve the superconvergence of discontinuous Galerkin finite element methods. And this is the references that I've been referred. They have 1, 2, 3, 4, 5, 6, 7, and 8 references that I referred to obtain all the informations for this topic. And lastly, thank you.